All right, this is balancing chemical equations. As you look at the problem on the screen, you might say, how in the world do you get that 2 for a coefficient sitting right here, and how does this all work? So this is going to be a walkthrough to show you the meaning of coefficients and how to balance chemical equations. All right, so let me hide a couple things real quick there. As we look at this problem, you have hydrogen 2, which really stands for this idea up here, where you have a hydrogen plus a hydrogen, and we write that as a diatomic molecule as H2, that 2 subscript standing for 2 atoms of hydrogen. Just like same thing here with oxygen, we have oxygen plus an oxygen equals O2, and so that 2 stands for a subscript, meaning that there are 2 atoms of oxygen and there are 2 atoms of hydrogen. So if we look at this side, we can say 2 oxygens, 2 hydrogens. However, when we get to this point right here in yields, when we combine those two together, we're left with hydrogen 2. So we see 2 hydrogens here, and here we only have 1 oxygen. And according to the rule of conservation of mass, they need to be equal on both sides. And that's not the case here. Now what we need to do is we're going to add some coefficients to help us balance the equation. And this is where the confusion comes in because, well, what does that coefficient really mean? All right. As we look at this, we're going to start by, okay, let's balance out our oxygen. We have 2 on this side, we have 1 on this side, so let's make sure we have 2 on this side. And so to do that, I add a coefficient of 2. Now what this 2 is really saying is I'm going to take this large blue 2 and I'm going to multiply that by the number of atoms that I have in this whole molecule right here. And so 2 times the 1 oxygen is going to give me 2 oxygens. And now I'm balanced. I have 2 on this side and I have 2 on this side. However, this 2, like I said, it applies to the whole molecule. It's almost like there's parentheses there. So 2 times the hydrogen and 2 times the oxygen. So this 2 means 2 times hydrogen, but there are already 2. So that's really 2 times 2. And so in the end, we have 4 on this side. So now we have 2 oxygens, 2 oxygens, but we now have 4 hydrogen on this side, but only 2 hydrogen on this side. Well, the good thing is we can add coefficients to both sides. So in the end, we can add a coefficient on this side, and now we have the idea of 2 times 2, which is going to give us an answer of 4. So 2 times 2 means now we have 4 hydrogens, not just 2 on each side, and of course there's not just 1. And so that's what the coefficients look like. Now, how would this, if we weren't using coefficients and we're really talking about the molecules and the atoms, the equation would end up looking more like this, right? To really balance this equation out, you need 2 hydrogen molecules and 1 oxygen molecule to give you, in the end, you're actually going to get 2 water molecules. But writing something like this out, this is a pretty easy problem, a simple problem, and so it's like, okay, that wouldn't be too hard. But of course, chemical equations get much, much bigger than just the addition of, to create water. And so scientists have said, let's do this a little bit more mathematically, let's make this simpler by just using coefficients. So this 2, the blue 2 right here, really stands for the idea that you have 1, 2 molecules. Just like this 2 here stands for the fact that you have 1, 2 molecules of the H2. And of course, since we learned about bonding already, we can now add everything up and write that's 2 plus 2 plus 2. Right? And now I have 2 hydrogen here, 2 hydrogen here, 1 oxygen, 1 oxygen, and in the end, we're balanced. All right. Try part 2 for another sample problem. All right, so now we're back at it, and we're going to try a second problem to help us really nail down this idea of exactly what's going on in this balancing chemical equations. So now we get a better understanding of what that 2 coefficient really stands for. It means you're taking 2, or whatever the coefficient is, and you're multiplying by the entire molecule. All right, once again, we have a problem here. And in this problem, we have 1 aluminum, right? We can see that here. And our oxygen plus oxygen equals O2, so 2. So we have 2 oxygen, and we have 1 aluminum on this side. However, when you add those 2 substances together, you get what's known as aluminum oxide. It yields aluminum oxide. But as you can see, once this new molecule that we've created, this new compound has 2 aluminum and 3 oxygen. And those numbers come back to bonding, because aluminum is a +3 and oxygen is a -2. So if you kind of remember that stuff, how you had to balance that stuff out to make sure that your bond actually happened. All right? And so it's building off of that concept. Then from here we can say, okay, if I have 3 oxygen on this side and I have 2 on this side, okay, I need to balance that to make sure that I have the right amount to make this work. So let's do that. All right, let's balance this equation out. All right. And my color chart doesn't want to go away. All right. Now it's gone. That's good. Here we go. So, where are we going to start? All right. We could start with aluminum and say, okay, if I have 2 aluminum here, I'll just throw a 2 right here real quick. Right? And now my aluminums are balanced, right? Because I have 2 aluminum, and I've gotten rid of that 1, and now I have 2 here and 2 here. However, our oxygens are still not balanced. And we need the 2 to equal 3. Now, as you think about this, coefficients always come in whole numbers. So it's kind of like finding that common multiple between those 2 numbers, and that's going to help you find your coefficient. It gets into the math in that sense there. So if we want something to balance this out, 2 and 3, we've got to find a common multiple, and the least common multiple in this case is going to be 6. It's not always the least common multiple, but in this case it is. So if we're looking to get 6 oxygens, right, I'm going to have to put a coefficient of 2 right here. All right, so I got my coefficient of 2 there. And so that 2 now stands for 2 times this entire molecule. So 2 times the oxygen, and there's 3 oxygens, so 3 times 2 is going to give me 6. Now on this side, I also need to have it equal 6. And so I'm going to add a coefficient of 3 here. 3 times the 2 is going to give me a coefficient of, once again, 6. So now I have 6 on this side, 6 on this side. Well, that's balanced. But we did something. We changed something. We took this 2 here and we put it in front of this entire molecule. And because of that, this 2 is now being multiplied also by the aluminum. So it's 2 times the 2 aluminum that are already there. And so suddenly we have 4 aluminum on this side. But that's okay. Because what we can do is we can erase this 2 right here, and we can instead put in a 4. I got a fancy 4 to come over here. And we got a 4. And so down here, we can say, okay, I had 1, and now I'm multiplying by 4, and now I have 4 on this side. So now I have 4 here and 4 here, and this stuff we found out doesn't work. Now, once again, we use the coefficients because it just makes things a lot neater and simpler, or else you'd have to write this whole thing out. Because really you have 4 atoms of aluminum, right? You have 3 molecules because there are 2 oxygen in each of those molecules, and in the end you have 2 compounds of aluminum oxide. Well, that's our walkthrough. Hopefully that gets you understanding how to balance chemical equations.